Good morning, everybody. Today's lecture is on backtracking, right? So let's start the lecture. The topic is backtracking, and backtracking is one of the problem-solving strategy. The strategy uses brute force approach, and the brute force approach says that we have already done the brute force approach. It says that for any given problem, try out all possible solutions and pick up finally the desired solution. In the brute force approach, you have to test for each and every option, each and every solution, and then you pick whatever is the final desired solution, right? So that is brute force approach. So backtracking is a technique, problem solving strategy which is based on the brute force approach. And please mind it, like we did the earlier approaches of greedy algorithm, the divide and conquer, dynamic programming, all those were a kind of optimization techniques. But backtracking is not an optimization technique, but with the help of backtracking, we can solve the problems, some of the problems. So first problem that I would like to explain that we can solve with this backtracking, and in this also I will explain what is backtracking. The first problem is rat in a maze problem. I will come to Sudoku. I have not taken the example of Sudoku, but Sudoku can also be solved using the backtracking problem. But I have taken the examples of n queens problem that I will come after explaining rat in a maze problem. But let's at present look at rat in a maze problem. Now, what is the rat in a? So I have written down this statement. There is a rat in a maze, right? There is only one entry. For example, I have tried to draw the maze, though it is not a proper maze, but still I have tried to draw it to explain the problem and how backtracking works and how you will get the solution. Now, for example, this is the entry point, which I have specified as start here. So there is a rat in a maze. There is only one entry and one exit. For example, this is the exit, and here is what a kind of cheese is placed. So rat has to reach from here to the last position to get the cheese, and then it can come out of the maze. A piece of cheese lies in the exit. So there are blocks in the path, but there are blocks, the shaded blocks are in the path, and this rat can take a wrong path because these shaded paths are a kind of block. You cannot pass these blocks, so it's a blockade there in the path. All right, and these are the move orders. Move orders means the rat will first try for a left move, then if it comes with if there is a block there, then it will try with the down move. If down move is also not possible, then right move and then top move. So these are the move orders which the rat can execute to finally traverse through the maze and reach to the final destination. All right. So let me explain what is the meaning of backtracking. The understanding the meaning of backtracking is very important. So the rat will start from here, and as I said, the first move will be from it has to move to the left. So there is a way to move to the left. So rat will start moving, going through the boxes, and it will reach here, right? So it comes to a block. Now it cannot move to any position. This we will call as the dead end. This is very important. So rat continues moving with the first option until it gets a blockade. It cannot move now any further. No forward move it can take. The point is that the rat cannot take any forward move, right? So it, what do we say? It reaches to a dead end. Now, what the rat is supposed to do? It is supposed to do the backtracking. Now it does the backtracking. From here it goes to there. It comes here. Now it can move a down position. Right, so it comes down. Again, when it comes down, it's a dead end. Right, so again, after that, it will have to move right. So it moves from right from here, then move here, and then it has to move left because the first priority is left, then it comes to a dead end, right? Then it comes down and then it backtracks. The point that I'm trying to explain is that the options are there for the rat to make moves. According to the priority level of the options, the rat will start moving and ultimately it will reach to the cheese. Now, how the problem works? The rat starts with the left move, it finds a dead end, it backtracks from there. What is the next possibility? Next possibility is go down, right? It explores the next possibility. Again, it finds a dead end, it then backtracks. After backtracking, it comes down, it finds the next possibility. I have explained it in this diagram, if you see. Now, this diagram is a general diagram of backtracking problem. It says that in a problem, you given the options, you start with the highest priority option. You start with the option, you move forward, you reach to a dead end. When you reach to dead end, you backtrack and gets on to the next movement. Again, you reach to the dead end, then you move backwards. That means you backtrack. You again consider the other options, move forward, reaches a dead end again. So when it reaches a dead end, it backtracks. During the backtrack, when it finds that a second option he can choose, again it follows the option and again it reaches to the dead end, so it backtracks. Ultimately, the point is that when after back until it reaches a square from it can move in the present problem, so it will start moving with the options given. So when it reaches to the dead end, it will backtrack. So when it backtracks and finds a new possibility, it will follow that possibility, and when again it reaches to the dead end, it will again backtrack, finds the next possibility as per the moving order, and further as the rat will go on doing like this, you will see in a maze that ultimately the rat will reach to the final position and it will eat the cheese there, and it will come out of the maze, or it will reach to the destination. So this is known as rat in a maze problem. Now let's look at Sudoku. I have not drawn the Sudoku chart. So what is the Sudoku problem? It's a 9 by 9 matrix kind of problem. So smaller squares are there, 9 squares along the horizontal side and 9 squares along the vertical side. So that means it's basically a 9 cross 9 matrix, or a 9 cross 9 square. That means 9 into 9, 81 squares are there. All right, and each Sudoku is I want to give it as an assignment to you that you try to solve Sudoku problem using backtracking. So in the Sudoku problem, how you can go in a 9 cross 9 Sudoku chart, what you can do is you can take a 3 cross 3 sub square. So what you will do with this square, you will have to identify the numbers where the number and you will keep on opting for the you take it as an assignment, right? The Sudoku problem. If you're not able to solve it, then I will explain in the next class how Sudoku can be solved using backtracking. The point is that you will keep on testing the numbers, which number is to be placed, starting from 1 to 9, right? You test 1 in the subgroup, then you test 2, then 3, then 4. If 1 is not possible, you backtrack, right? If you test for 1, then 2, 3, 4, if the possibility is not there, then you start backtracking. So basically, it's a problem to be solved using backtracking. All right. So the point here in this lecture, you have to understand what is rat in a maze problem. Sudoku as an assignment I'm giving to you, so you can solve it at your end. If you are not able to understand, I will come back to you again with the Sudoku problem also, and we can discuss. But it's very simple. You will not find any problem solving the Sudoku with the backtracking technique. I hope the rat in a maze problem is clear. The point is that the rat will start moving as per the moves. If it reaches to the dead end, it's very explanatory here in this example. It starts from here, it reaches to dead end, it backtracks, again finds a position to move forward, again finds a dead end, comes back, and so on. So ultimately, the rat reaches to the destination, or for that matter, in any problem which can be solved by backtracking. This is the technique. The technique says that you have to start with the options. When you reach to a dead end, you backtrack, then you make another move, other moves, reaches to dead end, comes back, and you can solve this. You can solve the problems using backtracking. So now let's look at one very important problem which can be solved using the backtracking. This is a very important actually example to be solved with backtracking. So the problem is n queens problem. To explain, the n queens is a generalized version of 8 cross 8 queens problem. So this example I have taken as 8 queens problem, but the generalization is the generalized version of the 8 queen problem is the n queens problem. But let's look at this chart, this chessboard. It's an 8 cross 8 chessboard. Our job is to place 8 queens on the chessboard. We have to place 8 queens on the chessboard so that none of them attack each other. That is, no two of them are in the, for example, this is a queen placed here, this is a queen placed here. So 1, 2, 3, 4, 5, 6, 7, and 8 queens I have placed. So if you know about chess, how a queen can attack another queen, it is when you there is no two of them are in the same row. If they are in the same row, they can attack each other. If they are in the same column, they can attack each other. If they are in the same diagonal, they can attack each other. So you have to place the queens in such a way so that they should not be able to attack each other. This is the final solution actually I have made, but we will see how we have reached to this solution. Okay, so I will explain what I have written here afterwards, but this I hope the problem is clear, that the problem is 8 queens problem we are discussing, basically n queens problem, but to explain here I have taken the 8 queens problem. Even I have considered the 4 queens problem also. So let's look at 4 queens problem. All right, now, and let's see how we can apply backtracking. So backtracking to solve 4 queens problem to start the example. That means we have to place the queens in rows. Only one queen can be placed in one row, because if you place the other queen, the first queen can attack. Now take a queen. Now I'm trying to solve what? I'm trying to solve a 4 queens problem. Take a queen and place it in the first available position. Now what is the first available position? Left position at the top. First position available is, so as I said, backtracking is based on the brute force approach. So you have to explore all the possibilities. You may start from the first. The first available position for the queen to be placed is left position, top. So queen 1 is in row 1 and column 1. So this is, the queen is placed here. All right, now we have to place the second queen. Second queen means we cannot place in the column 1, we cannot place in the column 2, because the queen has to come in the second row, somewhere in the second row. But we cannot place in the column 1, second row. I'm talking about the second row, so it cannot come in the column 1, it cannot come in the column 2 also, because it's a diagonal position. So column 3. So that means R2, C2 are not R2, C1 is not possible. R2, C2 is not possible. Place it at R2, C3. So I have placed the queen here. All right. Now let's try to place the queen, the third queen, in the third row. It cannot be placed at, I'm talking about third row now. It cannot be placed in column 1 because the first queen will attack. It cannot be placed in the second column because the second queen will attack. It cannot be placed in the third column. It cannot be placed in the fourth column. So what is this? This is dead end. You have to do what? You have to backtrack. Backtrack means you have to go to the second queen and adjust its position. So the only left position for the second queen is this, the column 4. So you place the second queen, in column 4. Now we have to now place the third queen in R3, that means row 3 and column 2. Now come back to the fourth. Now we have to place the fourth queen. But if you look at the fourth row, column 1 you cannot place, column 2 you cannot place because one of the queens will attack. Third column you cannot place, fourth column you cannot place. Again it reaches a dead end. So therefore R4 is again a dead end. So that means in that case you have to backtrack. Backtrack means you have to go to row 3. You have to adjust the position of the queen 3. But you cannot adjust the position. Queen 3 can't be changed because you cannot find any position where the queen cannot be attacked. So again backtrack further, reach to queen 2. Now queen 2, now it can also not be changed. The position of queen 2 cannot be changed, right? Backtrack, change the position of queen 1. So move it here as I have given in this solution. Move the queen 2 here. Queen 1 in the column 2, queen 2 in the column 4. Now queen 3 in the column 1. All right, you have to adjust, and queen 4 in the column 3, right? So what the point I'm trying to make is, again it is very similar to the problem of rat in a maze. It tries to find a solution, it reaches to a dead end, it backtracks. Then again it tries to find a solution by adopting the options. Again it finds a dead end, it backtracks, right? So let's continue with the n queens problem, right? So this is the final solution. Now you will see the queen 1 is in column 2, queen 2 is in column 4, queen 3 is in column 1, and queen 4 is in column 3. So no queen can attack the other queen. So this is the final, you can say this is the final solution for the four queens problem. Now let's look at a general case, right? Because ultimately we have to develop the algorithm for n queens problem. Now let's see how the algorithm can be explained. This R1 C1 means it's for queen 1. Queen 1 row queen, that means R1 C1 means queen 1 is at position R1 C1. R2 C2 means queen 2 is at position R2 C2. All right, so this is the terminology I will be using for explaining the n queens problem. Now think of the chessboard as a matrix for n rows and n columns, because we have to ultimately solve the n queens problem. So this terminology I've already explained. Queen 1 position is R1 C1. It will be explained as R1 C1. Queen 2 position will be explained as R2 C2. Now let us say let's take an example that the queen is at 4,2 position. That means some queen or queen 1, you can say queen 1 is at position at row 4 and column 2. That means queen 1 is at R1 C1, for example 4,2. I have taken this example that queen 1 is at row 4 and column 2. All right, now let's look at the situation. Now under what conditions does queen 1 attack queen 2? Queen 1 is at 4,2. Now I have to place queen 2. Under what conditions queen 1 can attack queen 2? Now it can attack when the column is same, when C1 is equal to C2. C2 is the column for queen 2. and C1 is the column for queen 1. When the two columns are same, one queen will attack the other. So this is first condition when column 1 is equal to column 2. All right. Now we need not to check the row because we know that we cannot place the second queen in a row where already queen is there. So we need not to check for the row. We have checked for the column that the first queen will attack the second queen if the two columns are same. Now let's look at the now let's look at the how it can because the queen 1 can attack the queen 2 diagonally also. Now I have said that my first queen is at 4,2. Now let's go further. Now possible positions of queens are 5,1. So if I place here, it can be attacked. If I place my queen at 5,1, it can be attacked. If I place at 3,3, it can be attacked. If I place the second queen at 2,4, again it can be attacked. It can be attacked while we are looking at bottom up, right? Bottom up diagonal. That means bottom to right. I have written here, this is bottom right, bottom right going towards the top. So what are the coordinates of the cells? The coordinate is 5,1, 3,3, then 2,4, then 1,5. If I place my second queen in these cells, the queen 1, which is at 4,2, will attack the second queen diagonally. Now the other diagonal is from here to here, from top left. What is top left? Now what are these positions? It is 3,1. If I place my second queen as 5,3, again it will be attacked. If I place my queen at 6,4, again it will be attacked. If I place my queen 7,5, again it will be attacked. 8,6, again it will be attacked. All right. Now let's look at this this diagonal going from bottom to top, from lower side towards the upper side. Now this says that what is the difference? What is R1 plus C1? My actual queen is at 4,2. So 4 plus 2 is 6. Now my second queen, what are the other options? 5,1, again it is R2 plus C2 is 6. 3,3 is again 6. 2,4 is again 6. 1,5 is again 6. So that means in all cases we see that R1 plus C1. What is R1 plus C1? This is my already placed queen, 4,2. What is R2 C2? I am looking for possible options. But I am looking for the possible options where the queen 1 can attack my second queen. So when this condition is met, that means when R1 plus C1 is equal to R2 plus C2, then I cannot place my queens in these positions, because then there will be then the queens can attack each other. The queen 1 can attack the queen 2. So I can modify this equation a little bit. R1 minus, I will take R2 in this towards the left side, C1 towards the right side. R1 minus R2 is equal to C2 minus C1. So this is my first. This is for this column. The diagonal going from bottom to up to the top. Now let's look at this column and try to establish a generalized relation that what are the positions. If I place my queen 2 at these positions, queen 1 will attack. Now the options are 3,1, 5,3, 6,4. These are the possible positions where I will place. If I place my queen 2, queen 1 will attack. Now if you look at 3 minus 1, 5 minus 3, 6 minus 4, these are all same. So that means R2 minus C2. That means where is my queen 1? It is as 4,2. So 4 minus 2 is 2, 3 minus 1 is 2, 5 minus 3 is 2, 6 minus. For this diagonal going from top to bottom, the condition is R1 minus C1 is equal to R2 minus C2. That means, what is this condition telling me? This condition is telling me, if this is the case, then I cannot place my queen at this position if this condition is met. If you remember, the first condition is when I have to place one queen, I have already placed one queen at 4, 2. I want to place my second queen. I cannot place in a cell where the columns are same. This is the first condition. Please remember that this is the first condition. If this condition is true, then the queen will attack. Now, coming to the second condition, I'm trying to establish the second condition. In trying to establish the second condition, the first case comes is R1 minus R2 is equal to C2 minus C1. Then queens will attack each other. The second option comes is R1 minus R2 is equal to C1 minus C2. Again, the queens will attack. Here, if you will see, R1 minus R2 is C2 minus C1. Here, R1 minus R2 is C1 minus C2. If these two conditions are met, then the queen will be attacking to each other diagonally. So these conditions are for diagonal. Now, I will mark it as equation 2. First equation I will mark it as equation 1. If I combine these two equations, then I can write absolute value of R1 minus R2. If it is equal to the absolute value of C1 minus C2, it will detect a diagonal attack. This will detect a column attack. All right. This condition, absolute value of R1 minus R2 is equal to absolute value of C minus 1 C2. This will detect a diagonal attack. So, keeping these two conditions in mind, let's try to further take the algorithm and let's try to write some algorithmic, and let's try to see how it can be solved. Now, queens on an n cross n chessboard can be explained using an array only. It's a it seems to be a matrix, but we can explain it to be an array. We can explain it using an array also. How? Index j I will take, which actually represents the row of the queen. The corresponding value, index j means which will traverse through the array. I am taking an array with the name of Q, right? If I have to move through the elements of the array, j is the index to traverse through the elements of the array. All right. So Qj is actually, so index j will represent the row, Qj will represent the column of the queen. Now let me explain from here. Now let me try to explain this. Q is the array. This chessboard can be explained with the help of an array also. Now this position, this is column, this is row 1. So this first position is Q1. That means index, and that means j is equal to 1. That means index is representing the row. Q of j, that means Q of 1, the value is representing the column. All right. This is column 4. Row 1. Now second index, which is j equal to 2, q equal to 6, that means this is the 6th column and row 2. Coming to the third position, what should be this? This is the third row, that means it is the third index. This is the 8th column, right? So therefore it is 8. This chessboard can be represented using a single dimensional array also. That's what the meaning is. All right, that's what I am trying to explain here, that Qj, this Q with the help of an array also I can represent the chessboard. Now this is general explanation. Whatever is written here, this is the general explanation for the backtracking algorithm. But let me come to this algorithm which we can use to explain the n queens problem, and we can further write the code. Now let's look at the algorithm. The algorithm says only one point I have to explain here, and the point is that I am trying to place queen 2 and I am assuming that queen 1 is already placed. I am trying to place queen 2 at r2 c2. All right. Now if you remember how we solved the queens 4 problem, we tried to place queen 1 in row 1, if you remember, the second queen in row 2, and the third queen in row 3, and so on. In other words, we only try to place a queen in a row if and only if we were able to place queens at all previous rows. So that means if, let's say, I am trying to place queen 3, that means I have already placed my queens at row 1 and row 2. If I am trying to place queen at row 4, that means I have already placed my queens at row 3, row 2, row 1. So that's how actually this explanation is for trying to put up a loop, because what I am trying to do in the algorithm, I am trying to place queen 2. Place r2 c2 means trying to place queen 2 in row 2 and column some column which will be defined by column 2. All right, 2 is for queen, because queen number 2. Now how the loop will run for, we will have to check all the rows, meaning by we have already placed the queens in r2 minus 1 rows. When I'm trying to place the queen in row number r2, that means I have placed all my queens from 1 to r2 minus 1, and these queens only can attack this queen. I have to find a position of this queen so that the previous placed queens should not be able to attack, right? So that is why this loop is from 1 to r2 minus 1. All right, now this is the column position I will get for the previous queen. The c1 means the previous queen. So this will give me the column position. As I have already explained, the value of the array will give me the column position. So I will come to know the column position of the previously placed queen. Now I will put my two conditions which I have devised. If column 1 means column of the previous queen is equal to the column of the next queen, that means there is an attack, or the absolute value of r1 minus r2 which we derived previously, and the absolute value of c1 minus 2. It is not 1, it is c1 minus c2. Then again there is an attack and we have to return false. False means that it is checking for the positions. That means this position is cannot be occupied. When we are trying to place the next queen, which is queen 2, at each and every position we are trying, then this position is false. That means we can put at that position 0. That means that position at that position we cannot place the queen. Now if these two conditions are not not true, that means these conditions are not met, then it will return true. That means that position is safe for placing my queen, so it will return true. All right, so this is the algorithm for explaining the n queens problem. I hope in this lecture, though the lecture I have not been able to face to face, and I mean it's not a regular class, but I have tried to explain the n queens algorithm, and I have written down each and every material, each and every step in my notes, so that you can, if you read through the notes, you will be able to understand the n queens algorithm and its solution. Further, if you find any problems, you can ask me when we can take another Zoom lecture for clarifications. I will take one lecture for clarifications where you can bring your questions, or when the college opens, we can discuss at that point. But it's a very only point to remember is that the queens have to be placed in rows, and they have to be placed starting from the first row, and they have to be placed in rows in such a way so that when queen 1 is placed, Queen 2 has to be placed at that position in the second row where the queen 1 cannot attack queen 2. That's what this algorithm is basically doing, right? And if you find any difficulty, most welcome to ask any questions. My email is open, WhatsApp is open. You can ask questions.
Excuse me, sir.
Yes, please.
Sir, if all conditions return false, then what should we do? How will it backtrack?
But all conditions will not, you see, then in that case, the solution does not exist. But if this, for example, in the rat in a maze problem, if I block all the paths, right, then the rat will not be able to reach to the final position.
No, sir. Like we have to backtrack also. If the row is if the row has no option to be filled, then we'll have to go to the previous queen and try to move it. How does that happen over here?
In the code you are trying to ask?
Yes, sir.
No. It is only the forward move. This algorithm is explaining only the forward moves.
Okay.
You will have to modify the algorithm, of course. This is I am trying to explain. When you will write the code, actually full code, you will have to take care of how you will backtrack. Your point is absolutely correct. Then when the position you are not able to fit in, then you will have to backtrack and move the other queens also. Right? So that part you will have to include in the algorithm. But this is a smaller algorithm. And maybe in the next lecture, I will try to cover that part also about the backtracking.
All right.
This is not including the backtracking. That means now you understand what is backtracking. So in the next lecture, algorithmically, how we will involve in the algorithm the steps to incorporate backtracking. That I will explain in the next lecture. Don't worry. All right. So I finish my lecture here. Thank you so much. And if you have any further question, tomorrow also there will be lecture at 12 o'clock. I will post the idea and all. I will do this backtracking part only, so we can discuss more at that time. Thank you. Thank you very much.